So let's go make that collider. And we essentially have it already here, but we're going to make some other colliders later, so let's kind of collect them in one colliders area. This must be green. So I'm going to turn this off, go in here, object merge, let's go get that thing. So I'm going to say the out, just click and drag it to here, so you can see that's what we've got. We will have another collider later. We could put a merge here, or we can literally just add to it here. So actually it's a little silly. More importantly, we can do a collision source. Now collision source does two things. It has two outputs. One is the regular polygon geometry output. The other is a VDB output. We're going to need both technically, although the polygon one usually matters more for moving objects. I'm just going to set it up this way for completeness. This will calculate velocity per point. In the same way, if you're used to using the trail to compute velocity, it's going to look at the previous or next frame, or a combination of the two, and make a V attribute, which it does. Of course, our V attribute is just nothing, because it doesn't move. So in any way, this is essentially the same exact thing as the input. More interesting is the volume output. I mean, to be honest with you, if you go look in here, it doesn't do that much. I mean, this is, as far as like these preset tools go, it really doesn't do that much. But anyway, we do it here because it's a nice little like convenience thing, and you know, it's nice to standardize this stuff a little bit rather than reinventing the wheel every time. So on the volume tab, it's going to make a volume called collision. There we go, like so. The voxel size, remember we were just talking about that? That's going to come up a lot. Here's the first time we want to do this. Copy the voxel size here, paste it here. You can paste, for all these things for the record, you can paste absolute references under other if you would rather it be like that. I'm just going to keep doing the relative references because it's just slightly easier. In any case, so there you go. We have a volume representation of our ground and a polygon representation of our ground. And again, to reiterate, the polygon one is usually used for moving objects when it has to read the actual velocity of the surface. So we'll come back into our simulation, like so, and let's put a static object down. So what are we going to put in here? We're going to want to get the polygon representation goes under the SOP path. And if we look at this, we've got our polygon geometry, but the volume is actually more interesting to us in flip land. Flip is being done oftentimes in a voxelized grid, as we talked about. So the volumes, the collision volumes themselves, are of the utmost interest to us. So let's look at it. In fact, let's just hide other objects. So this is the volume it's generating for us. Say, the more divisions we make, the more high resolution it is. Thing is, this volume has a tendency, the way that the static object calculates it, it's not always the best. It's also not always very fast. However, our collision source here uses VDBs to do it. And as we kind of talked about a minute ago, it's in there somewhere. As we talked about a minute ago, VDBs are very memory efficient, and at least they are created quickly. So although the VDB is going to be turned back into a dense grid in the simulation, it's nice to, instead of it calculating itself, let's use the one that we just made. So go to volume sample, and then down here under proxy volume, which is kind of a weird way to call it, because the actual volume, we copy this in. And now it's going to it's just going to sample that into the simulation. So now if we change this, it doesn't matter anymore. It's using the one from out here. Or more accurately, it copies it into the simulation as a dense grid now. So there you go. If we press play, wow, it actually collides with it. So it's pretty easy. So while we're in here, I'm just going to say, let's turn the collision guide back off. Let's turn the display geometry back on. Or actually, let's keep it off for a second. There's one more thing you should know. You often have to debug colliders, especially if you have moving colliders. Now, we won't have moving colliders, but I do want to touch on this anyway. On the flip object, under the initial, or rather under the guides, there's this collision visualizer. And this is probably the best way to really understand that. See the dimensions of this blue box here? That is actually the extent of the flip sim right now. Remember when I said that the bounds here are really only the maximum bounds? This is actually what it's simulating. Just the liquid and some areas around it. This purple here, from our guide, is what flip is actually using for its actual collisions. We went through several hoops here. We had polygon geometry that we created ourselves. We had a VDB that was created from that. Then that was in turn copied into the simulation, into the static object thing here, and then the flip solver itself then samples that. And that is what we end up here. It's the collision field in the flip object, not the geometry of the static object. It's copied into the flip object. Because the flip object has its own set of resolutions. As we were saying, we have our particle separation, we have our grid scale. You can actually change the resolution of the collision here, which we don't really need to do, but you can do that if you want. So the point is, the higher the resolution gets in here, like if we were to right now, say go to 0.5, or even like 0.1, back in here, you'll see the collision is way more high res now. See? So this is the kind of thing that we need to debug, is the actual collision guide in here. Now, there really probably won't be any collision issues in this lesson, but again, especially if you take this lesson and start having like animated characters walking through your rivers and things like that, which by all means that would be cool, and please send it to me if you do. You'll probably have to debug it, and that's how you'll do it. Cool. So that is our first collider. We'll make some rocks later on.